Hi to the host students, Mr. Kaczynski with you. About to do the 6.2 practice your skills exercises. 6.2 is over exponential functions. Here we go. Rewrite each expression using exponents. Okay, well, I see a repeated 7 being multiplied here, so that's going to be our base. And then our exponent will be how many times it repeats. 1, 2, 3, 4, 5, 6, 7, 8. So we'll say, oops, why did I say 8 and write 3? All right, so how about 7 to the 8th power? There we go. Maybe I was looking at this one already. So here we've got a base of 3, and then we also have a base of 5. So here's what we'll do. We'll write it like this. Got the 3 and the 5. The 3 repeats 1, 2, 3, 4 times. And the 5 repeats 1, 2, 3, 4, 5 times. So 3 to the 4th times 5 to the 5th is how we would rewrite that using exponents. And this one, you see the 1 plus 0.12 repeats. And how many times does it repeat? 1, 2, 3, 4. Now, you might say, well, can I make that 1 to the 4th plus 0.12 to the 4th? Let's check and see that out, or check that out right here. Let's do it on a calculator. So here's what I'm saying the answer is, and I'm sure that that is equivalent to this. People might be asking, could we write it as this? Could we apply that 4th power to both the 1 and the 0.12, like this? Well, let's look at a table, and let's see if those are the same thing. And you can see that they're not the same thing, okay? So I guess I didn't need a table to do that. I could have just done it from the home screen, but whatever. All right, so that's each of those. Bacteria culture grows at a rate of 20% each day. There are 450 bacteria today. How many will there be tomorrow? Okay, so that would just be the 450. And then we're going to multiply that by the growth rate, which is, well, it's growing by a rate of 20%. So we're actually going to multiply it by 1 plus 0.20. Okay, and what will that give us? 450 times 1.2 is 540 bacteria. How many will there be a week from now? Well, we're going to take that same thing, that 450 times the constant multiplier of 1.2. And since it's 7 days and not just 1 day, we'll do to the 7th power. Definitely want to use a calculator to help us out with these. We don't want to use recursive rules anymore either, because the equation is the shortcut. So we'll say about 1,612 bacteria. Gross. Matching equations with the table of values. Okay. Well, a couple things we need to look at. How about we jump to the ones that are actual exponential, which are these right here, which have the x as the exponent. I think this is our starting value, and that's right there. Okay, so that makes this table 3. B is 3. All right, whereas, maybe I should have wrote that in green. Either way. So I'll do from now on. This one I can see starts at 2, but so do both of these. Okay, which one gets multiplied by 4 every time? Do it like that. This one gets multiplied by 4 every time. X goes up by 1, y gets multiplied by 4. So this is IV, number 4. That means this one is being multiplied by a fourth, isn't it? 0.25. See that? So they start at the same place, but they're being multiplied by something else. So this is 1. This one over here is not exponential at all. It's actually quadratic. Yeah, so it's actually 1 squared is 1 times 4 is 4. 2 squared is 4 times 4 is 16. 3 squared is 9 times 4 is 36. And that's square the number, then multiply by 4. So that's number 2. Matching recursive rules, okay, with equations. All right, let's start here. Starting at 105. Starting at 105. That could be this one or that could be this one. But we're multiplying by 0.95. There that is right there. All right, so that is 4. As opposed to this one, which is multiplying by 1.05, which would be this one, right? Yep. There it is right there. So same starting value, but slightly different. Okay, so that's 2. These both start at the 0.95. One's got plus and one's got minus. I think that becomes pretty clear, doesn't it? This is the 1 plus the 1.05. Maybe I should show it right there. And this one right here is 1 minus. It's being multiplied by every single time. Yeah. So that's going to be 3. For each table, find the value of the constraints a and b such that y equals a times b to the power of x. Okay. To check your answer, enter your equation into your calculator, and then we'll see if this table matches. Okay, so we're going to go y equals our starting value, which is 1.2. And then we need to figure out the multiplier here. So you can see this is doubling every time that x goes up by 1. So that'll be 2 to the power of x. Let's check and see if that works. Clear these equations. Which weren't really equations. 1.2 times 2 to the power of x. Checking our tables. And 1.2, 2.4, 4.8, 9.6, 19.2. So we got it. All right, let's do it again. Y equals, our starting value this time is 500. What's our multiplier though? Well, maybe we'll go back to the home screen. We'll do 200 divided by 500, or 20 divided by 500 is 0.04, just like 4 divided by 20 is 0.04. Or, ooh, no. What happened? Oh, I see the little tricky part here. We need to add some values in here, don't we? You know what? Maybe I forget about that one. Let's go. See, these are consecutive right here from 2 to 3. As this goes up 1, what happens here? And that's the one I just did, which is 0.2. So if I go 500 as a recursive rule, enter, times 0.2, that gives me 100. So when x is 1, y would be 100. And when x is 2, y would be 20. And when x is 3, y would be 4. 4, y would be 0.85. Okay, so that's working. So our multiplier here, not sure why I used purple, is 0.2, or 1/5, I guess. 4 over 20 is 1/5. And to the power of x. I think we already checked it with the recursive rule, so we don't need to check it with a table here. And they're trying to mess with us here on C. I think I'm going to use this and this here. So as x goes up 1, what happens here? 20 divided by 50 is 0.4, also known as 2/5. So you could call it that I really should have multiplication sign there. Multiplying by 0.4 or 2/5, whatever. Do we have our starting value? We don't have the starting value. What are we going to do about that? All right, so 0.4 to the power of x, but we got to go backwards and figure out the starting value. So what's the opposite of multiplying by 0.4? It would be dividing by 0.4, right? So if I want to work backwards to figure out when x is 0, what's y, right here, I would need to divide by 0.4. 50 divided by 0.4. I think it's 125. So now we'll go back into y equals and we'll check this. 125 times 0.4, also known as 2/5, to the power of x. Checking the table, there's our 0, 125, 150, 220, 5, 1.28 is right there, and 7.2048. There it is. We got it. Not sure why I boxed that in green, but whatever. All right, this equation models the amount of money in a savings account that earns annual interest. Explain what each number and variable means. Okay. Well, y is the balance of the savings account. Let's see, x is what? The annual interest, okay. The number of years that have passed. 500 is the starting account value. 0.04 equals, I hate when it does that, 4% annual interest. That's what that means. And what else do we need? Well, the 1. That means that you're not going to, that means that you're going to have 100%. You're always going to keep the 100%, but then you're going to gain 4%. All right, last one here. The equation, table, and graph represent 3 different equations. List in order of increasing y-intercept. All right, this has a y-intercept of 1. This has a y-intercept of 3. And this is going to have a y-intercept of 2. That's its starting value. So, increasing order, we're going to go the graph, then the equation, then the table. Which 2 situations have the same pattern of growth? Well, let's see. This one's tripling. This one's doubling every time x goes up by 1. What's happening here? That goes to 2. So up 1, or an increase of 100%. And then what happens here? Does it double again? It looks like it does. So this one goes from 2 to 4, so it doubles as x went up 1. So that's going to be the table and the graph that have the same growth pattern. Which will have the greatest y value when x equals 10? Well, the one's tripling probably will have the greatest y value when x equals 10. So I think that's what I'm going to say. I'm going to say I don't like that it's doing that. How about we'll say, we'll do it like this. I, and then we'll type it in. Because it has the biggest growth factor, which is 3. You know, we can check that too. 2 times 3 to the power of 10. That's huge, 118,000. This one is doubling. We started at 3, and then there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Not even close to what the other one was. This one starts even lower and doubles, so it's not even going to be as big as the table. All right, that's all I got for you. Practice your skills 6.2. Hopefully you found some mistakes. If you didn't find any mistakes, man, this stuff's too easy for you. Anyway, or maybe you just found some ways to do this stuff different. All right.